Hello everyone, I welcome you back to my YouTube channel. I wish you all a happy new year and may the Lord bless us all. Amen. So in today's video we have this question that we have to find the term independent of x. The term independent of x in the expansion, the binomial expansion. X plus 1 on x all raised to the 6th power. Okay, so this is the question we have. After this one we will solve one more question, then we bring the video to an end. So we have this binomial expansion and we have to find the term independent of x. In other words, what this question means is that we have to find the constant term in this expansion. Okay, so solution. So we have this binomial expansion plus x. Okay, now we know in general any binomial expansion is in the form a plus x all raised to the power n. Okay, so this is the general form of writing a binomial expression or a binomial expansion. Okay, so we know if you want a specific term in a binomial expansion, this is the formula we use, that is n combination r multiplying a raised to the power n minus r, then multiplying x raised to the power r. Okay, the n is the power of the binomial expansion. R, there's a formula for r, we will get there. A is the term we have over here, x is this one. Okay, so if you have to compare x plus 1 over x all to the power of 6, if you have to compare it with a plus x whole power n, our n will be 6. Okay, based on their positions, our a will be x, and then our x, because they are the same x, let me replace this one with y, because the same x, just to avoid confusion. So y will be 1 over x. Okay, so that means this will now turn to this power n, then the formula will be this, a n minus r dot y power r. Okay, this will now be the formula because we've replaced the x with a y. Okay, so if these are the values of a and y, then if you want a specific term, okay, if you want a specific term, replacing n, r, and then y with their values, we get 6 combination r multiplying a is now x, so x raised to the power n minus r, so 6 minus r multiplying y, which is 1 over x all raised to the power of r. Okay, now for this type of questions, okay, we want the term independent of x, that is the constant term. Now for the constant term, the power of the x is always 0. Okay, so if you have something like 2 is the same thing as 2 multiplying x raised to the power 0. Okay, so for the constant term, the overall power of x in the expansion should be 0, or in that term should be 0. So what this means is that if we are to multiply this exponent of x, we should arrive at 0. That is how we'll be able to get the constant term. The x terms we have in this expansion is x power 6 minus r multiplying 1 over x all power r. Okay, so since we are finding a constant term, the overall power of x here should be power 0. So you just have to look for the parts where you have the x terms, then you work on it to get an overall power of 0. So because the overall power should be 0, that means we just have to solve this equation for the value of r, which when we replace it in this expansion, we will get an x power 0. Okay, so we just have to solve this equation for the value of r. So we have x power 6 minus r. 1 over x is the same thing as x power minus 1, so multiplying r gives us power minus r equals x power 0. Okay, so because they are multiplying, for the laws of indices, to multiply a number or a term with the same base, you just have to add the exponents. So we get x raised to the power 6 minus r, then plus minus r equals x power 0. They have the same basis, so we just have to compare the exponents. So we have 6 minus r equals 0. So 6 minus 2r will be 0. 2r will be equal to 6, then r will be equal to 3. Okay, So that means if you want the constant term, you just have to replace r with 3 in this expansion. So that will be 6. Replacing r with 3 gives us 6 combination 3 multiplying x power 6 minus 3 multiplying 1 over x all power 3. Okay, so we get 6 combination 3 multiplying x power 6 minus 3 is 3 multiplying this gives us this, so that they will cancel out. Then the constant term will be 6 combination 3. Okay, so you just have to use your calculator, or if you know the value, you just have to just write the value as your final answer. So using our calculator, 6 combination 3 is 20. So our constant term for this expression will be 20. So this will be your final answer. All right, so let's solve one more question. For the next question, we have this answer question. That's the coefficient. I want to write the full question. So the coefficient of s cube in the expansion of k plus 3x all power 4 is 54. Okay, so we have to find k. Let's find the value of k. So we have the coefficient of x cube in this expansion. This expansion we are dealing with. The coefficient of x cube in this expansion is 54. So we have to use that to find the value of k. So solution. Okay, so just as we compared the previous expression with a plus x all power n, we do the same. So n will be equal to 4. Our x, let me make this as this. Our value of x prime will be 3x. No, you just have to look for the term that contains an x. The reason why the value of a over here was x is because both terms contains an x. So when it happens like that, you can just give it out to any one of them. You can make this one an a or this one an x. So for this question, a could have been 1 over x and then y could have been x. We would have still gotten the same answer. Okay, so that was just by the way. So x prime will be 3x and then our a will be equal to k. Okay, so it's a specific term, that is an s cube term. So the formula is this: a power n minus r dot x power r. Okay, n is 4, so 4 combination r multiplying a is k, so k raised to the power 4 minus r multiplying x, which is 3x all power r. Okay, so it's an s cube term. Okay, so that means the value of r over here should definitely be 3. Okay, so you just have to replace r with 3, so k raised to the power 4 minus r, that's 3x all power 3. Now this is the value of the s cube term, but from the question, this value, the coefficient of this is equal to 54. So that means the s cube term is the same thing as 54 s cube. Okay, so we have 4 combination 3 multiplying k power 4 minus r. 3 cube is 27, so 27 s cube will be equal to 54 s cube. So definitely these s cubes will cancel out on both sides. 4 combination 3, I think it's the same thing as 4. 4 combination 3 is the same thing as 4. So 4 multiplying k raised to the power 4 minus r, the multiplying 27 will be equal to 54. So we just have to solve for the value of k. We can divide through by 27, so cancel out, we have 2 over here. So we have 4 multiplying k power 4 minus r being equal to 2. Okay, so dividing through by 4, we get k raised to the power 4 minus r equals half. Okay, which is the same thing as 2 power 1. But what was the value of r over here? I forgot to replace the value of r in this one. So r is 3, so we get this equals 2 power minus 1, it's minus 1. So we get k, 4 minus 3 is 1, so k will be equal to 2 power minus 1, which is the same thing as half. So our value of k will be equal to half, or 0.5. Okay, so thank you for watching. Please do well to subscribe to my channel, like the video, comment, give your suggestions on videos that I should make. And yeah, thank you for watching once again. I'll see you in my next video. Once again, I wish you a Merry Christmas and a Happy New Year. Goodbye.